Well, so I think there's sort of three interrelated challenges, and that would be policy, the business model, and then technology. But I think we need to look at, from sort of what's the main challenge we're trying to solve, is we need to look at the operational challenge that the utility has, and then try to understand what technologies would enable that. So one of the big challenges that utilities are facing from an operational perspective is how do they get visibility and control in the grid, particularly in the distribution grid. So they haven't needed it in the distribution grid in the past, and now suddenly with all these new assets coming on, not just distributed generation, but electric vehicles, they need to figure out how to get that same level of control that they have in the transmission side. When they look at the tools they have, the current tools they have, such as SCADA, supervisory control and data acquisition, they struggle to see how it will scale and how it's going to be cost effective. So along comes the Internet of Things. And Internet of Things, the acronym for that is IoT. What that does is it says you can use internet protocols to do a lot of the same visibility and control that you could do with other systems. But you need to secure it, you need a whole bunch of infrastructure to enable that to work. So what Intel does is we basically provide a lot of the infrastructure for the Internet of Things. What that enables the utility to do is then figure out how they can build on top of that, build the applications that they need in order to run their grid. Intel makes processors, and we've been doing that ever since the company's been founded nearly 50 years ago. And we continue to drive down the cost of processing. The other thing that we have invested heavily in is on the software side. And so we invest in software that optimizes how other application software can run on our processes. We also have software like McAfee security software that enables us to provide security from the edge, from the device such as a solar panel or a solar system or an EV charging station all the way through to the cloud. On the cloud side of things, we've invested heavily in software standards and open source software to enable the whole cloud architecture to take off and to enable companies to make better use of big data. So we provide software in various ways at various stages across the grid. And so we have a hardware layer of infrastructure, and then on top of that we have a software layer of infrastructure. So I think the grid is going to move through various stages. I think right now we're at the visibility stage, and if you think about that in terms of solar, it's where is that solar being produced? You provide a heat map of the solar. Then we go to management to say, where do we want the next solar plants to be? Where do we want the next storage to be to enable us to manage that? And then we start looking at control. And control is in various forms. So some control is, I need to predict something a day ahead or an hour ahead. And then you get down into microsecond control. So I think the Internet of Things will progress through these layers. Eventually, we'll move towards much more of a software-defined grid where software is making many more of the decisions than we'd previously done. That's not going to occur today, but I think companies need to think about where is the technology going, because we need to aim where we're going to be in 5 to 10 years, because that's the time scale over which we're going to be rolling things out. I think what Intel's going to be doing is we'll continue to drive Moore's Law, continue to drive down the cost of processing and drive up the speed of processing. But in addition, I think you'll see us move closer to the customer to understand how what we have can enable them to create experiences for themselves and for their partners and for their customers.